Okay, so today what we're going to do is we're going to review over 9.3 about composite figures. Let's look at this first shape right here. So for problem number 1, it asked us to find the perimeter of the figure. Remind me again, class, what does perimeter mean?
The outside.
The outside part. So basically what I'm going to be doing is I am going to be adding up all the sides on the outside. Do you see that there is one side that there is no number?
Yeah, it's the same.
Yes, this is the one. Do you guys know what that number should be?
3.
You're right. You figured it out because if this was 3, that means this over here is also going to be 3. So I'd like you guys on your actual figure, just put a 3 there. Now, we just talked about it. We're going to add these numbers together. So let's add this 3 plus 6 plus 3 plus 5 plus 5. And that is going to tell us the perimeter around the outside of that composite figure. All right, Kyla, what'd you get? 22. Now, we're just going to write 22 units because it doesn't tell us if this is feet or inches. Should I square those units? No, why not? It's not the area. The only time you square the units is when it's the area. How many of you would say, when you look at that, that seems pretty simple? Okay, that one seems fairly simple because there's no rounded edges. We didn't have to find circumference or anything like that. We just added the straight edges together. I want you guys to do problem 2 with your partner. Okay, so looking at question number 2, let's just identify a couple things. You see 2 shapes there. What's one of the shapes you see?
Triangle.
Not a square. A square would have equal sides. A rectangle and a triangle. Very good. Now there is one mystery side. What is this amount? That would be 5 units. So when you add all these together, 12 plus 5 plus 13 plus 5 plus 5, what do you get?
40 units.
40 units. Should I square them?
No.
No. Once again, we were only finding the outside perimeter, or the distance around the outside of the figure. Going on to number 3. This is where it's a little more complicated. Can someone tell me why this is not as easy as the first 2 figures we did? Heather?
Because it's different and it has 2 6s, but one is inside.
Okay, so this 6, yeah, it did tell us that it's on the inside. What's the hardest part, Kyla?
We have to find the circumference.
We have to find the circumference. That part right there, this distance around the outside of, what is this shape called?
A semicircle.
Okay, the distance around the outside of the semicircle, we don't know. What is the outside of a circle called?
A circumference.
Circumference. We've learned 2 formulas for circumference. C equals 2 pi r and C equals pi times d. Looking at this, this gave me the distance all the way across the bottom of our semicircle. What is the distance all the way across the circle called?
Diameter.
Diameter. So which formula do you think I should use? Should I use C equals 2 times pi r or C equals pi times d? Let's use this one because it did give us the diameter. Okay, so guys, one thing is still not okay with this. That's the formula for a circle, circumference of a whole circle. We've got to divide it by 2. Okay, now once you do that, that is going to get you the outside part of the semicircle, and then you can add all the sides together. I want you and your partner to work on that together. Okay, I saw a lot of good. We saw 3.14 is pi. What was my diameter, class? 6, and then I've got to divide that by 2. Because there are no exponents here, I am allowed to cross reduce. This would become a 1 and a 3. When you multiply that together, what do you get?
9.42.
Okay, so a lot of people told me the answer was 9.42, but guys, this question mark is 9.42. So I can actually erase the question mark and stick in that this would be 9.42 units. Now it's asked you once again, find the perimeter. So we're going to add 9 plus 6 plus 9 plus 9.42. And that gives us what the perimeter would be. When you add those things together, what did you get?
3.42 units.
Should I square those units? Why not?
Because it's not
All right, I know you might feel like, why does she keep asking us the same exact question? It's because a lot of people messed up on their units on their quiz, okay? So just remind yourself, always you're only going to square the units if it asks you for the area. Any questions on number 3? Okay, I'm going to do one last final example with you. Okay, now the instructions on number 4 have asked something different. It does not ask me for the perimeter. What's it ask me for? The area. So if you remember, asking for the area means what is the space in between here, okay? In order to find area, we've got to figure out what 2 shapes we have here. Guys, what are the two shapes you see?
semicircle and a triangle.
Okay, so I want you to write here. The area is, all right, so the first shape that we've got there is the semicircle. What did you say the other shape was? Okay, so we're going to add together the semicircle and the triangle formulas. First things first, what is the area of a semicircle formula?
Pi times r squared divided by 2.
Everyone say pi r squared divided by 2.
R squared divided by 2.
On your quiz, I saw a lot of people cancel out the 2's. Why can I not cancel that out?
Because they're squares.
Okay, this is an exponent. That's a square. That means multiply by itself. That does not mean the number 2. So those cannot cancel out. When I hand your quizzes back to you in just a bit, you'll see a lot of people, I wrote a note, you cannot cancel out a square. Okay? Then we have to add in the formula for a triangle. Guys, what's the formula for a triangle?
1/2 base times height.
1/2 base times height. Now, I've talked to you about this little tiny square on a triangle. What is that little tiny square? A right angle. Remember, the right angle helps us to identify where the base is and where the height is. And if you remember, let's just reposition this to look like this. There's my right angle. You'll see the tall part is 24 and this part is 10. This right here was our dotted line. Okay? We don't need to do anything with that diagonal. So do you guys see, according to this, which one is my base?
24.
The 10 is the base. Which one is my height? The 24. What about this dotted line? Is that anything? That's the diameter of our semicircle, okay? So right now we're not going to use that for anything when we actually start plugging in those numbers. Let's talk first about our semicircle. You guys just told me this was the diameter of the semicircle. So if the diameter of the semicircle is 26, what is the radius?
13.
How'd you get that?
26 by 2.
Divided it by 2. She cut it in half. So what I'm saying is I only want to know what this point to that point would be. Half of that was 13. So now we're ready to start plugging in our numbers. Caleb, what is pi? Very good. Gerard, what is the radius? Now, right now, we're only focusing on the semicircle. What's the radius of the semicircle? 13 squared divided by 2. Now, let's just focus on our triangle. Half times the base. Class, what's the base?
10.
10. What was the height?
24.
Very good. According to this formula, what do I need to do first? Exponents. What does 13 squared mean?
13 times 13.
It means 13 times itself. So if you guys would, figure out what is 13 times 13? 169. Okay, so we've got 3.14 times 169 divided by 2. Is everyone following? Okay, let's go on. Plus, what is half of 10? 5. And then what is 5 times 24? 120. I want you and your partner to find the remainder of what the area of this composite figure would be. Let's talk just about the semicircle. When you guys did 3.14 times 169 divided by 2, what did you get?
265.33.
265.33. And then we needed to add the area that we had for our triangle. What was your total answer?
385 squared.
Why did you square your units?
Because it's area.
Because you were finding the area. How many of you would say you got that correct? All right. Hopefully that was a good reminder of how to work with perimeter and area of composite figures.